magnetic field will be in circles, will be produced in circles when the current okay. If we hold the wire in such a way that thumb is indicating the direction of current, then magnetic field will be along the curl of the fingers. Okay, so that will be the anti-clockwise in circles. Okay, so this will be a magnetic field. Okay, D will be that will be an anti-clockwise.
Yes.
Okay, so this is a B, or this is also a direction up, because magnetic field along the line. So we will consider this. Okay. So what is the angle between B and L?
What is that?
L is also along this path, the path along the magnetic field. So so angle will be a 0. We will consider the circular okay, B dl cos 0 to L mu naught I 1 . We are considering the constant current. Two ampere, there is no change in current. When there will be a change in a current, there will be change in a magnetic flux. That is the next topic. That is not topic. That is our topic is that if the current is constant. Okay. So if the current is constant, there is a no change in the magnetic field will be a constant. Okay, and we are considering at and we are considering the point at r distance, constant distance. Okay, so that's why B will be constant for if radius r is changing, then B will be changing. But for particular orbit for, radius r, the B will be remain the same. So it will become out the sign of integration. Yes. What is the length? What is the length of circle? What of the length of the circular path? That is will be circumference 2 pi r. Okay. 2 pi r. So this will be your understanding. So this will be magnetic field due to the, there will be, because it is a closed integral, we will not apply the integral, you are right. So we will draw these circles, not a 0 to L. So this will be and this L will be a 2 pi r close, and that will. Okay, next topic is find the magnetic field due to solenoid.